Welcome, everybody. My name is Peter Blazer, and I'm going to act as the host of today's webinar. And in today's webinar, we're excited to share with you. It's entitled Getting Started with ArenaFlow 12.0. And we recently released ArenaFlow 12, and we're planning to tell you about what's in it and also demonstrate the new features. You might have questions as we go. So please know this webinar will be recorded and will be available for playback typically within 24 hours after the webinar on our website. In fact, you can find all our webinars at cpfd-software.com/resources/webinar. And I don't expect you to actually remember that. So if you go to our website, there's a resources. When you click on that, there's going to be a drop-down menu with presentations, webinars, and that's what you're seeing here, where we record webinars about releases, customer webinars, presentations, and some new application models. So you can find all our webinars recording there, and this one will join it shortly. In the meantime, for those of you here live, we want this to be interactive, and so you'll see a questions panel in the GoToWebinar drop down there. So please ask your questions as you think of them. So as we're going through, if I say something, Thomas says something, and you're really not sure about that or have a follow-up with what it could mean, put your question in there. We've allocated lots of time for Q&A at the end of this, and we want to make sure we get your questions answered. Before we get into ArenaFlow 12, let me introduce our company and product. There's a mix of people here, a lot of existing users, but also some that are looks like checking us out. So first of all, CPFD Software, here as a company, we are advancing multi-phase simulation and technology, and we do that with specialized software. We've had that for gas particle systems since 2003. And as a company, we have two main products. ArenaFlow is Foundry-specific software for sand cores and molds, and that'll be the subject of today's webinar. And we also have Barracuda Virtual Reactor. And this is general purpose software. It's for broad applications for fluid particle systems, such as fluidized bed reactors. It simulates gas particle and liquid particle flows, and it's coupling the multi-phase hydrodynamics, the gas particle or liquid particle motion, with heat transfer and chemical reactions in industrial units. So if you go to a website, you see things about Barracuda, that's what that is. For the rest of this webinar, let's talk about ArenaFlow. So ArenaFlow is software and services for sand cores and molds specifically. It's designed to help you get tooling that's right the first time, taking that trial and error process and replacing it with virtual testing. And this is a timely thing to do at this point in history, as we have a lot of retirement for people with the historical knowledge. This is a way of capturing, retaining, and disseminating that core-making knowledge via the software. Everybody wants to eliminate scrap, but with ArenaFlow, by looking inside your tooling and virtual space, you can understand what's causing it first to help you eliminate that scrap, and other benefits, optimizing cycle times, minimizing consumable usage, the dosage, increasing uptime, extending tool life, and ultimately this is all aimed at reducing costs, capital costs, operational costs, and energy savings. So let me show a few different application areas for ArenaFlow. The first is core blowing or shooting. What we're seeing here is three different views of filling an automotive, a cylinder head water jacket core. On the top, we look at the sand coming in and the overall compaction. In the middle, we're looking at not just does it come in, but how it comes in, what is the speed at which it comes in, and then how that slow-moving sand affects density. So at the bottom, you're seeing the resultant core density after filling. Also for cold box systems, we have curing, where you're looking at the progress of the curing front through the core. You can see areas that are first to cure, last to cure, the areas that might have difficulty curing, to give insights into how to minimize cycle time and dosing. And it's not just for cold box, it's for inorganic systems as well. So here you have the added complexity of hot air and hot tooling, looking how the air temperature and the sand temperature interact with one another, and then ultimately driving that moisture that is inside the core in the sand as the binder, how that vaporizes and let's play that one more time. How that vaporizes and goes into the gas field. So looking at the time at which things cure and avoiding over drying. And it's not just for individual cores. ArenaFlow is used to model full systems of magazines, looking at how the airflow interacts with the sand in the magazine, which could affect different cores differently. And finally, I should point out that ArenaFlow is a tool that's used for a variety of processes. It's well known for cold box systems. We've shown in organics, but also shell sand systems. There's a lot of shell sand out there and a lot of people using it. Now you have different complexities with parting line venting or ejector pins, those scratch vents, and even green sand, the filling of green sand molds. So if you have a system and it's not on this list, talk to us. If it's a sand air system, that's what ArenaFlow is designed to model. We could talk through what's a good fit. A few things, and then we'll get into the ArenaFlow 12 release. But again, for those that are new to ArenaFlow, a few reasons why ArenaFlow is a tool of choice for sand cores and molds. And the first, and one of the most important, is the discrete sand particles. The sand in ArenaFlow is not assumed to be a continuous media. It's not a modification to a CFD where for a liquid code. Instead, these are discrete particles. Each one has its own size and other properties. So you can capture things like particle size distributions, from a sieve analysis. You can have mixtures of sand, different densities of sand, and additive materials can all be captured natively in the ArenaFlow method. And then that sand, those discrete particles, as you see here, are pneumatically driven by airflow, enabling to do things like flow uphill or not flow uphill, depending on the air. So here we're looking at the venting at the end of these two arms. When there's very little sand, it's just high airflow. And then you see the high sand speed. As that slows down, as there's little airflow, there's little sand motion. And this is natively captured by ArenaFlow. And as a company, this is what we do. Coming back to 2003, when the Howard F. Taylor Award from the American Foundry Society was presented to ArenaFlow and General Motors for a joint project, presenting work that became the ArenaFlow product. Some of the early work, training, both domestic and internationally. We were honored again in 2010 with the Applied Research Award, again for work done with General Motors. And we're honored to have Thomas Brandt join us this year. And he comes in with 35 years more experience, and we'll introduce him in a moment before he does the demonstration. Another thing, the post-processing is quite powerful, easy to use, enabling you to look at the results and understand not just what will happen with the core or your tooling, but why. And we are partnered, whether it's as an AFS corporate member with tooling providers, machine providers on the software side, and even on the compute side. So if there's a need you have that goes beyond just simulation, us and our partners can come together to meet that need. And finally, we are here to support you as an ArenaFlow customer. So for those of you who do have access to ArenaFlow, maybe have downloaded or about to download ArenaFlow 12, please contact us if we can be of any assistance, whether that's with the setup, the post-processing analysis, even some core making questions. And with that, let's get to the topic of today's webinar, which is ArenaFlow 12. So now, first of all, ArenaFlow 12 is available for download. So the way you download ArenaFlow is you come to our website, there's a login section, click on that. If you don't have an account or a customer, you are entitled to one. In fact, if multiple users at a company, you can each have your own account. When you log in, if you don't have one, there'll be a sign up button, we'll activate that. When you log in, you're going to see our two main products, Barracuda Virtual Reactor and ArenaFlow. You'll see that the current release is now updated to 12. You can download the Linux or Windows versions, access the release announcement, and actually access the user manual as well there. So you can always have access to the latest materials in a searchable format. So it is available for download. The main capability in ArenaFlow 12 is the ability to initialize sand from a previous simulation. So here in this graphic, I'm showing a fairly large core, which in this case looks like it was filled with a single blow, but there's many times that doesn't happen. So now you have a capability in ArenaFlow 12 to say, I would like to set up another simulation, but let's keep the sand from the core and refill the magazine. Or you could say things like, let's look at how the sand falls into that magazine. Will it fill it out? Also curing after blow. So instead of assuming I have a uniformly filled core, what happens if I have density variation? So you can run the blowing simulation first and then move over using those results, the varying density in the filled core, and run a curing simulation with that density variation. How does that affect? And so the big major difference is as you go in, instead of just initializing and specifying sand in a region, you could say initialize from a file, which comes from a previous ArenaFlow calculation. And there's some other enhancements. I mentioned the user manual. On the main panel, we used to have this expert interface, which I think nobody outside of our company was using. So we've replaced that with a user manual button. If you had, for some reason, used that expert interface, you can still access it through the command line. Contact your support team, happy to help. And some other things that Thomas will demonstrate is support file creation. With each release, we update to the latest tech plot version at the time that we're developing. And so you continually see updates in the post-processing. And enough from me. At this point, I'm going to turn this presentation, this webinar, over to Thomas. So Thomas Brandt joins us. He has 35 years, more than 35 years experience in CAD, CAM, pattern making, tooling design, simulation software. In fact, he's worked with the ArenaFlow software for nearly 20 years now, and we are just so happy to have him join us this year. And he's our manager of Foundry products and services. So with that, Thomas, I'm going to change the presenter over to you.
Thank you, Peter.
There. And then you can take over the screen.
Thank you. So, you should see my screen. And yes, again, just thank you. So again, as Peter pointed out, I will walk through the changes and updates and improvements we've done to version 12. The first one is, as you see, on the GUI, main GUI, we now have the user manual button. I will click that and just shortly demonstrate. So what that does is it opens a locally installed copy of the enhanced user manual on your computer. And then you can do step-by-step, click on any item, it will be listed, and similar to what we are showing today, our main point of interest, the send location, you click on send location, and then scroll down and you'll see the send initialization, which is where we have added features. So this is a very useful tool, step-by-step guide, and easy to access. So let's jump into a model, a setup, just to show a little bit of another few features. Again, if you do not if you want to open the user manual and you're not going just to jump back to the main GUI, you can actually also access the user manual from the help menu. Click on help and you see there's the user manual. So it is also accessible within any module of ArenaFlow. The other thing is that we have added back in is the create support file function, which in event you have something that you would like our support team to take a look at, you would create support file, help create support file. This file, this function will create a zipped folder file of any information that we need in order to help you. This file is stored inside the ArenaFlow project directory, so your current project folder, that's where the file is stored, and then you would either find a way to transfer it to us, either secure file transfer options, anything that works for you. This file is going to be large as it is incorporating the restart and the send files, the co-IC files, which we'll show later. So I'm not actually going to create a support file, but it's a very useful function for us. So rather than just going through the GUI again, I'm going to go to TechPlot and open our TechPlot screen. So here's our typical scenario. We have a blowing setup. We got sand in the head and the tubes. We play that and see how it performs. And fairly early on, we'll see the tubes start to run out of sand, red holing. So it becomes pretty obvious that this core is not going to fill. Let me just pause that and speed up the simulation a little bit, as there's not a whole lot going on any further other than you see a few particles that are, but in a sense, now we have a result. We got a half-filled core. We got a magazine. So what happens next? Well, let me show our regular. So this is kind of the option we would have in the past, right? We could do from a hopper, we could do a gravity fill, and then potentially model some sand locations manually to mimic the way that the sand was introduced from the previous simulation. But how about if I were able to actually bring over the end time result from the first blow and add that to my second gravity fill and then take a look. So let's see what happens if and how we could get to this point. Right, you see everything carries straight over. The particle locations carry straight over. Right? So let me go back into ArenaFlow. And the change we've done is found on the sand location. That's the only thing that's changed. In this case, what we do is we have, in the past, we had initialize. Okay, this is how your screen would look in past versions. Standard setup, but we added the initialize from file. There's a file name defined as always. If we were to change that, go to start a new project, in order to just click on the three dots to browse back to the first initial simulation and pick the last time step. So that's it. That's a key to go to initialize from file. On the drop down, change from initialize to initialize from file. And then we can go back to tech plot, we can play this simulation. So we got a gravity fill, no pressure applied, just sand falling under the influence of gravity. So this is going to run to 2 seconds, so we can see, take a look at what's filling. The blow tube starts to fill up. Obviously, we got, in this case, some particles that is dropping into the cavity, but gravity feeding from our hopper. And we see that there's not a, let me speed this up a little bit again. It keeps continue to go up to the 2 seconds. So you can see a little bit of, obviously the head is not filling out completely. But here we are at the 2 second mark. So then, now that's great, right? We established that we got enough sand in the magazine to actually restart a calculation. A second blow. Let's see again. So I removed the hopper, but here we are. We have a core that's half full. We got something that's dropping down. So let me go back and change the time step. And we can play that. We can see now it's again a pressurized system, and as entering the cavity, dragging sand along. So it's fairly short fill time for the remaining portion of the core. Again, I'm just going to use the checkbox controls and speed up that movie a little bit. And see how it's just, sand is just shifting in the magazine under pressure, but and again run to 1 second. So 3 stages of blow now, and yeah, just waiting for it to reach 1 second. So it's nice to be able to use TechPlot and just have the 3 scenarios side by side. So that's the functionality illustrated in TechPlot with regards to transient blow. As Peter mentioned, we also do transient curing. And here we got on the left side, we got a uniform traditional setup, uniform porous media. On the right side, we got a core blown. So we see the higher density underneath the blow tubes and a little bit across. In the center images, what I've done is I have reduced the scale to highlight, highlight the differences between areas cured out fully and areas that potentially will cure out when the core sits on the shelf. So there's obviously an amount of residual curing, but this is the 4 top views are cross sections right across the center of the blow tubes. And at the lower two images, we're just showing the progression of the gas front as it moves through the cavity. And when it turns transient or clear, it's transparent or clear, it's representing a cured sand. So let's just play that. And we're using the, we're not showing any blow tubes or any other, not blow tubes, but any air inlets, other than we have applied venting directly on the core surface as air inlets, which is kind of the method that we typically apply. So we do not have any sand restrictions above the core. You see, they are pretty similar, except that we can see how the two side areas in the dense core, or not the dense core, but the core where we actually use the density, the particle volume fraction from the blow for the porous media definition, is showing slower to cure areas. And it will run to 20 seconds, and slowly we see the turquoise green turning dark blue as the air makes its way through those denser areas. And if you ask why there's not the same pattern in the center of the core, well, you can see a little bit here, but it's because there's significantly higher amount of exhaust right in the center. So that's it. Let me go back into the GUI to show the way that this was set up. Same thing, sand location. We have our traditional porous media definition. And then from the drop down, we just added, again, initialize from file. So this is what I had to show for this demo. And I hope you got an idea of how we can use a core IC as a valuable tool to add a lot of features, new information that we can now use and extract using ArenaFlow. So I will hand it back to Peter.
Thank you, Thomas. Pull up the controls again. And we're about to get started with that Q&A. Thomas, feel free to take a breath and a sip of water. If you have questions, we have some here. But if you've not yet asked a question, get those in. We'll start the Q&A in just a moment. In the meantime, for those of you that are new to ArenaFlow and this webinar, I do want to briefly point out the ways you can get started working with us. We do offer several different engagement mechanisms. Our primary is software licensing. This is where you as a company and as a user can use ArenaFlow in-house, and there's a wide variety of ways to do that. It's possible to do that. Most do it still on-premise, but some companies prefer cloud licensing options, so you can run on-premise or on the cloud. It is supported on Windows and Linux operating systems. That is native on both now that we have the TechPlot post-processing. We also offer services. So this could be for troubleshooting individual cores, everything from that ranging up to broader design services on core box packages. Training, technology transfer. Obviously, we have new user training, we have advanced training. We can customize that training. And one thing that's really neat is this quick start program where we combine training, services, and licensing. So we can set up the first core or cores for you and then transition that over for you to run in the future and train you on your own cores. And we're always open to R&D and other partnerships and collaboration opportunities. So please contact us if there's a way we could work together. And a few ways to try this yourself. We can do a software demonstration like we're doing here, to do a live demo on a web meeting. And there's some ways to customize that to do demonstrations using your own data. And consider joining us for a training class. Training could be combined with trial licensing, and this could be web-based or in person. So with that, we're going to get to the questions. Keep them coming. I have a few here. So Thomas, if you're ready, first one here says, can I run successive blows without refilling a magazine?
Yes, you can, and that is a very neat feature. You can actually sort of cycle through scent levels, which can help to determine if there is an core quality related improvement from having maybe run a little lower than expected. This kind of sweet spot, scent level, height, that will give you the optimal core quality. So yes, you can definitely cycle through scent levels or scent heights using the previous and then just restart a new blow.
Thank you. The next one says, why was there sand in the core at the end of the first blow? And I think this is referring to the three views you had when you blew the first core and then refilled the magazine from the hopper and so forth. There was some sand at the top. I saw it too. Can you comment on that?
I can, but if you would allow me to share my screen again,
yeah,
I think I have a.
Yeah, I'm sending that back over to you.
Thank you. So I actually prepared a little tech plot setup here to kind of illustrate what is going on to answer that great question. So when the end of blow, we still have a pressurized system. We are not turning off the pressure. It stays on. So as you can see, we have pressure. That pressure is actually, that air movement is keeping the particles up front, right? The aerodynamic drag are lifting those particles up in the core. So this is end of blow. The colors on the geometry is representing the transient pressure. On the right side here, we have the second blow. And it's but if I start to play that, and it's blue because everything falls on gravity, there's no pressure applied. So when I start that, just step through it a little bit, we can actually see that the particles are now dropping just from the influence of gravity. So I hope that answers the question.
Yeah, so in the first case, you left the pressure on. So at 1 second, it's not like we turned off the machine and watched the wind down, but rather stop the blow at one second where the air is still flowing, and it's that aerodynamic drag that's holding the sand up to the vents. And then so when you turn that off, there's no, in the second one, that's just the gravity filling, is that right?
Yes, that is correct.
Okay.
There's no, I mean, we typically do not model the exhaust on the core machine. We could do that, but for blow, we rarely do it.
Yeah.
It's more common for gas. So.
Okay, let's see here. You showed cold box curing using blown sand can you also do this with inorganics? I think this is talking about the curing after blow. So is that available for inorganics as well, and other considerations there?
Absolutely, that's a great question. We can do exactly the same thing. It's again the same thing on the inorganic module. You just select the initialize from file to use a previous send location. So yes, it has definitely the same functionality, and you can analyze the dehydration on
okay. So the initialize from file is available in all the different modules.
Yes.
Great. I'm asking some questions here because I've run hundreds, thousands probably of simulations, but it was over a decade ago. So I'm actually learning some of this myself now. Next question, how do I get a trial? Let me address that one. So we do offer trial licensing. The way we do that is we combine that with training. So we want to make sure you get the most out of trial. So contact us. We'll talk about your situation, what might fit your needs best, and we'll sort you out and getting started with ArenaFlow. All right, this one. Is there an option to import the defect location model to map the defect onto the core box model? And I don't fully understand the question, so if the asker could clarify, but I think it's saying, so let me read it again. Is there an option to import the defect location model to map the defect onto the core box model?
So what, I mean, I'm not sure if fully understand, other than if you like wanted to overlay a defect that you saw in reality. You would do that using an image. You can import it. You can add an image in TechPlot. So you can use that. You could import an image and overlay that on the core, but to get the physical send locations, what you ideally would do is you would run that simulation in ArenaFlow, and you should see an apples-to-apples comparison, and you should see that defect. And then you could, then you got the send locations, then you can overlay that, and yes, use that as the foundation for an alternative flow, if that was the question. So
well,
let's say
I'm speculating it could be asking about like for core gas generation. So if you have a varying, density in the core, and then you're running a core gas model, that's not specifically what it says, but I'm wondering if that's what's meant. In which case, it's my understanding you can always take, you can view things in TechPlot, but there's always ways to get the raw data out. Now this would probably involve some scripting or something, but you could dump that raw data, have the particle density, volume fraction locations, and then if there's a way to import that into the other software, then that could be done, because it is possible to export. I'm not sure how easy that would be, but we do have people here that are quite familiar with scripting and automation. So okay, I'll move on. A couple more here, and then if you have any others, we have a couple left. Please ask those, and when we wrap up the Q&A. Does the support file automatically send information? If so, what is sent?
It does not automatically send, and maybe that was a little unclear. It creates a zip archive, and that zip archive contains the project, the data needed to rerun and recreate the project, along with some ArenaFlow runtime, along with the log files from ArenaFlow. That's typically the information that is contained in the support file. And
that's really important, I think, for IT and security concerns. Often when we're supporting people, we say, hey, send us the files, and they say, well, what files would you like us to send? And so this is a way of answering that question easily without having to be overly specific in each case, but it does not send this to us. So every company, I mean, we've gone through this the last couple months with different companies have their own protocols for sending data, and so we can use whichever one is suitable for your organization. Unless another one comes in, we've got one last question here. Thomas, why was there so much difference in curing when using the Core IC sand density middle image? It says. I think you might have addressed this, but this came in earlier. But it could be a good one to show. In fact, I stole the screen back.
Yes,
let me. Up? I'm going to change the presenter back to you.
Yes, thank you.
If you pull up that image.
Yep.
And address the question. So again, why was there so much difference in curing using Core IC?
That is a good question, and I probably didn't explain that very well. But when you look at the scale, it is really highlighting the issue. Okay, if we change the scale, it will, and it's not necessarily, that the core. This is not going to be loose sand, right? It's still 80. It's still around 94-95% cured, so it's very limited. So it's little just to highlight that because of the venting scheme, we're pulling air through both the dense air, but also a lot of bypass of air is going through these areas and curing out the center, and then slowly it will make its way and cure the two ends.
I see. So the bottom is, your overall view that we typically see, is it cured or not? That scale looks like it's from 90 to 100%. So this is more. Would that mean more, perhaps trapped amine, or I mean, you wouldn't want it on SO2, but perhaps not purged well?
Yeah, I mean, you can see it's just gonna be a little harder to purge out the last amine in the two core, in the two right and left side of the core. And that's, I mean, I think from process view, it is helpful to be able to model it on a using the send location from Blow. There are catalysts that will actually require the core to be 100% pure, have had 100% air contact. If not, there will be loose streaks of sand. So yeah, it's I think it's helpful. It's more just an added layer of accuracy.
One more question that just came in. Could you please explain how the simulation runtime is determined? Is it dependent on the number of mesh cells?
So yes, the resolution impacts the runtime. There are two factors: the mesh size and how many particles that you are using. And I assume this is pertaining to core blowing, which we got a lot of moving parts. So yes, that the resolution and particle count is determining runtime.
Yeah, I think that's the case with every CFD. I think it's interesting. When I first joined in the early 2000s, I asked the founder, Ken Williams. I think we just came out with Pentium computers from a 386 and a 486, and it was so exciting to have this new technology. And I said, is this game changing? Our simulation's going much quicker. And he said to me, well, and he quoted an early customer, said, he had at that point been doing CFD for over 20 years. And he said, my experience is it doesn't make things faster. I thought that was really stunning, because we had this great new technology as this Pentium computer. And he said, such and such company, they have a policy, they want the best answer they get in about 24 hours or maybe 18 hours. And the reason is the engineer can look at the model from the previous day, set up one, run it overnight, come in and get another answer and try another case. And this has almost held out. It is faster now typically, but what I'm seeing invariably is the engineers are doing much more finer models, more detailed resolution. including more physics in cases. So blowing is entirely dependent on meshes, the number of mesh cells and computational particles. We've seen some with millions of cells and hundreds of millions of computational particles. I don't necessarily advise that, but you can always do a finer mesh resolution to get finer answers. But as computers speed up. But it is dependent, and I think for the person who asked this, we are here to help. So we can help with resolution studies, finding out what is maybe an ideal resolution for your system to make sure you're running the right system. So happy to chat through that. For curing, I will say it is super fast compared with blowing, and even Thomas, I think even with the variations in core density, that doesn't affect the runtime for curing. It's still really fast.
No, you're correct. It does not.
We're not modeling the sand moving during the cure, whereas the extra complexity.
Just I mean, a typical runtime for cure, it has to be fairly extreme if it takes more than 1 hour to run a curing, even on a family box. You got multiple cavities, high resolution. You maybe have, like, for argument's sake, 5 million computational cells in the grid. It's because single phase, right? It's just airflow, gas flow. It's extremely fast, and the most blow today, even I would say, run easily within a day and a half, even though for reasonable, fairly complex cases. Obviously, it's hard. It's also hardware dependent to a certain degree, but it's certainly a very useful time frame.
Okay. Another question came in while we're speaking. Do we have any viewer software option to review the results without using the main simulation software? And let me start that answer, and if you know otherwise, Thomas, feel free to chime in. Right now, TechPlot is the main post processor that we use. I think there might be still options to write the old GMV files. I'm not sure. So I see the person who asked that. We'll answer that one directly. But I will say that we do have options. It's not a standard offering, but for some companies, you may have a main user that needs full access to software, and then others who might just want pre-post access, and that is possible to arrange without having the full solver. So this might be more of a commercial answer. Technically, Thomas, do you know if there's other viewers? I think the beauty is that TechPlot just does everything so well and so natively. So we'd rather find a way to get access to TechPlot than around the free software.
No, I concur with that answer. I would say, reach out if that's the case. Find a solution where you may not buy a license, but you'll pay. I mean, you do not need the solver, but we do have the pre and post option in some package, and that's something that Peter can elaborate on. But I would strongly recommend that we work towards a solution where that the question, the asker gets access to TechPlot.
Yeah, and we'll figure that out. And the team at TechPlot's pretty awesome and easy to work with. So we'll come up with some arrangement, but we'll reach out directly on that. I don't see other questions that have come in. So with that, Thomas, I'm going to thank you for taking the time for the demo, and I really want to thank everybody for joining us and your attention through this webinar. If you have other questions that come up, contact us. We do have the info@cpfd-software.com email, or you come to our website and there's a contact button, fill that out, and we'll be in touch. If you're an existing customer, you know how to reach us with the support email or contact us individually. Be sure to follow us on LinkedIn and let us know how we can help. And with that, we're going to conclude the webinar, and we hope to continue to help as you get started with ArenaFlow 12.0. So thank you, and this concludes today's webinar.